Guys, welcome back to the channel. Ron from New Record Day, and this gentleman right here is Clayton Shaw from Spatial Audio. If you are brand new to my channel, welcome aboard. Certainly glad to have you. If you're into anything hi-fi, audiophile related, make sure you hit the subscribe button, make sure you like. And what we're doing today is kind of a little different. This has been fun, man.
I know.
It's been cool.
Live sit down. I love it.
Yeah. This video is essentially answering a lot of the questions that you guys had in that teaser video, and then kind of peeling back the layers of those questions and diving right into this. Before we even get to the review, we kind of wanted a good place to jump from. One thing that I want to mention is that video, it's got like over 11,000 hits. 11,000 views, and there's like 100 comments on there. Clayton and I wanted to, show the viewers the respect that we stayed up pretty late last night and we read every single question. We thought about it, we talked about it, we had bullet points, what do we want to answer, and essentially what we did is we started finding the common threads, the common questions that were coming up time and time again. So we had to pull out some of those that
we can't answer all of them, but some of them are really relevant and most people have kind of the same questions in terms of what's going on with this type of design. So
yeah, I think we need to be able to answer a lot of the questions up front with like, why do you do what you do, and how did this what's the big deal with Open Baffle? Like,
exactly.
Is Spatial Audio going to come out with a box speaker next week? No. No, it's not going to happen.
Yeah, so first of all, I didn't invent Open Baffle, so and most people know that, but it's actually been around a long time. I ran into, in doing some, like, looking back at some of the retro literature from movie theater days, I actually found a JBL subwoofer that had three 15-inch open baffle woofers for movie theaters, and that kind of shocked me. I was like, wow, and I don't know anything about it other than that, but it's such a simple idea to put a driver on a baffle that it's not rocket science in that regard. But we'll get into why we're using it, though. There's some things that are going on with speakers in rooms that I think it kind of makes it a requirement to go this direction.
Yeah.
So we're not doing it to be different. We're not doing it for some crazy reason or some untested or unvalidated reason. This is just basic science, and it's easily repeatable in terms of you can measure in your own room and see the same effects in any room. But the way I like to talk about it is that my background was with you guys as an audiophile going back into the 70s, and I was a speaker designer early on, got involved as a teenager developing speakers, but I didn't know any of the things that we're going to talk about today. And I developed box, conventional, audiophile type box speakers for a long time through that period into the 80s. And then the super short version is I ran into a friend of mine, Stephen Burgess, who's a really smart guy that I knew at that time. He had built a prototype of a open baffle subwoofer that had three 15-inch drivers in it again. And I was just floored at how much faster, and not faster, but more detailed and less boomy and muddy that was. And I was sold right there. And along the way, a lot of other people have found the same thing, like Danny Ritchie, we've seen on the channel before, knows this. Siegfried Lindquist found this out too through measurement. It's like, this really works, but it's not, obviously, it's not apparent how to get good performance out of it unless you really dig in and figure out what's necessary to make it work well. So anyway, so is it okay to start out that way and just say, I'm not any different than anybody else as far as speaker designers go, until I had a moment like that where I encountered something different that I thought was obviously enough better that I switched gears immediately right there. So that's one thing. And then another thing was that I was still, it was all about consumer audio, though, audiophile this and that, and I was around that type of gear. But in the mid to late 90s, I went to work for a large professional pro sound speaker company, and that was a brain burner. I mean, the stuff that I ran into there really kind of woke me up to what was happening in areas that we weren't talking about in the audiophile world. And one of them is dynamic range. And a lot of guys, like many of you guys have heard a big horn system, know what I'm talking about. If you've ever heard a big Klipsch horn or a big avant-garde or something, it's like, wow, there's a whole different world out there when you start talking about, immediacy, dynamics, low-level detail, things that are going on with high-efficiency speakers. So high efficiency is one of the things I brought with me out of the pro experience. Another one was the fact that you need to control the way the speaker radiates energy into the room. Okay, in that business, we call that control directivity.
Yeah.
And it's just simply, the speaker's broadcasting this energy out there, and the properties are different when you go through bass, mid-range, treble, because the wavelengths are different. The wavelengths are really long in the bass, really short in the treble. So the way they, just a quick example you would probably figure in the treble range, it acts kind of like the billiard balls thing. It's like what we call ray tracing, where you just see it bouncing around the room, whereas when you get into the long wavelength, the other end of the spectrum, it's more like a pressure field effect. And so since the properties are different, you have to treat the way you apply your product idea to it differently. So that pro industry gave me a lot of information that I didn't have and I wasn't hearing. In other words, the other guys that I knew in the industry, if you said, hey, how about control directivity? They'd look at you like, I don't know what you're talking about. Okay, so if you can, and in fact, I'll get into that and I'll show you why that's important in a minute, but the pro sound industry is where I brought the information that allowed me to kind of fuse these two things together and create a product that has advantages from both industries in one product, because they tend to kind of be one or the other. A lot of the pro speakers have these great properties, like they're super dynamic and everything, but they may be weak in other areas, and a lot of them have horn coloration and things that is fairly easy to hear, which might not be a problem in an auditorium or something, but if you're right in front of it, it's audible and not acceptable. So I think you have to be real careful about looking at what is the application, what are we doing with the speaker. So okay, so that's the overall look. So the way I like to say, why do you do this? What in the heck are you doing? What I'm doing is I'm not designing a speaker as a standalone thing that exists to do a job, because that's fine if you're going to listen outdoors or in a really large room, but home audio, the audiophile market is not about that. It's about playing music back in a 12 by 15, 15 by 20, some kind of a room.
Everyday rooms.
Or an everyday room in a house, so what we call a domestic environment. That's where the problem comes in, and that's actually the number one, in my view, problem in audio, not just speakers, but in audio.
Yeah.
And you hear people, like, man, the room's a big deal and all that. Well, when you get into speaker design, you better really pay attention to it, because you're generally fighting the room is toxic to the signal that's coming out of the speaker, because it's contaminating the linearity and timing and a whole bunch of things. Or it can, if you don't design a product that is designed to be independent of the room as much as you can. You can't do it, obviously, completely. But so that's why my designs end up being, and some other ones that follow this general idea, that's why they tend to be this way. In fact, that's a good reason to segue into why open baffle. Well, because there's a simple method to create a directional bass beam that is not perfect, but by eliminating the energy coming out of the sides and top and so forth, the peripheries, because of cancellation, we end up with what's left over, which is a forward lobe and a rearward lobe.
Like a figure eight, essentially.
Like a figure eight, kind of looking, if you look down from the ceiling, it looks, theoretically more like a figure eight.
Yeah.
And you say, well, why do you do that? They assume that's because, well, yeah, it makes sense, because if we could get rid of the box, it would probably just sound better. You don't hear the boxy sound. And that's true, but that's not why we do it. I mean, the main reason is that and we'll show this in a diagram in a minute, it's real simple, but basically domestic environments are too small for box speakers because the boundary's right there. The sidewall's right there. The floor's right there. The ceiling's only 6 feet above the speaker. And you get interference patterns that just ruin the frequency response linearity and cause all kinds of interference patterns that screw up imaging and tonal color. Everything is kind of messed up. Not only that, but you can't predict what's going to happen if you're a manufacturer. If you make a speaker and it's room dependent and it's affected by these room effects, then how are you going to know what customer A, B, C, and D are going to be experiencing?
You have no idea.
You don't
You're
know.
guessing
You're
at best. L-shaped room, tile rooms, heavily carpeted. It's like, who knows?
Well, that's right. And a lot of this is dimension driven, and you don't know what their dimensions are, or the particulars of their couch and all this different stuff that's in the room.
Yeah.
So it's good practice anyway to try to make your room acoustics room independent, because you want to be able to know what's going to happen in an installation, if nothing else. So open baffle, we use it primarily for that reason, because bass is the area where you have the most problem. That's where the wavelengths are long enough to where you get cancellation effects between these close boundaries.
Yeah.
So in our design, you still could lengthwise, because it's still there is energy going longitudinally into the room, but the distances are a lot greater.
Yeah.
Right? Not only that, but we have to hear bass. We have to generate bass. So we end up with basically something like a directional bass beam, which is a huge advantage.
Yeah.
In terms of solving a lot of the room interaction problems. But it goes. The issue goes higher all the way through the spectrum also. It's just that the solution to dealing with this is different than it is in the bass range. And that's why you've seen things like a waveguide to control the treble propagation angle and all that. So really, ultimately, what you want is, and it's what is meant by control directivity, is to have a what we could just call a broadcast angle or propagation angle or dispersion pattern that is known and is as consistent as possible. In most regular speakers, you see a lot of, if you map the dispersion angle versus frequency, you see that it's pretty wavy. It's all over the place. So at different frequencies, the dispersion angle is different, and that has to do with the different drivers and their properties versus the wavelength they're trying to reproduce. So that's why we split it up into 3 ranges and deal with each one according to what you have to do with the difference in wavelength. So again, a waveguide would be a good way to deal with treble versus open baffle for bass. So you start seeing a pattern here already, is that we're not even really talking about speaker design. We're talking about the room.
Yeah.
Okay, this is the really big secret in all this stuff, is that how do we know? In other words, you have to listen. The speaker that you buy, you have to listen to it in your house.
Yeah.
Okay. And you're lucky because you have a room that's pretty big and it sounds natural and all that. But even then, you've had problems, I'm sure, with speakers, because most of them are not designed at all to deal with what we're talking about. So that'd be fine if you're listening in an anechoic chamber, but you're not, right? So to me, it's all about the room, because if we created a speaker that has perfectly linear response, and then the room contaminates that, then what have we done? What's the point?
Yeah, I almost feel like in my experience, with all the speakers that I reviewed, if we're talking about like a traditional box speaker, it seems like placement for me is based on getting away from the bad things to land on a place where it works best. With open baffle, it's almost as if I'm using the room to just keep getting it better and better and better. It's almost like using the room to its advantage, whereas with the box speaker, it's almost like the room is always fighting back until you find a place like, okay, this will work.
Yeah, it feels like a compromise.
Yeah, it's
like,
a compromise.
I finally found some place
that
doesn't sound booming.
Yeah, it's one of the things I love about open baffle is it's actually fun to mess around with placement, because you can get some it's just like we're going from good to better and better to amazing, and you're just
I think you're absolutely right. And you found that by using it and experimentation. I found the same thing. I think it's a product like the M3 or anything that's designed similar to that is very easy to get very good sound. You can just plop them down and walk off.
Yeah,
but
we haven't moved. Just so you guys know, we plopped down the M3s where we kind of were like, yeah, we got some tape down. Let's try this. We haven't touched them. Scout's honor, and we're just like, oh,
and it sounds good.
That sounds good.
but that's what's cool though, is you're rewarded. I mean, you are too with the regular speaker.
Yeah.
You know, as you work with it, it gets better. But yeah, you feel like there's a lot more distance you can go. Instead of trying to make it not suck,
Yeah.
it's already good, and you're trying to, and then you can work with it to make it better. So
Yeah.
it's really kind of fun.
Yeah.
So anyway, that's the overarching approach here. Idea is like, it's not. I wouldn't use the word symbiotic, because you know the room is not working with the speaker. It's not that sort of thing, I think room independence is probably the best term I can think of anyway.
Yeah.
To where if A, B, and C room are completely different, I still know that we're probably going to get good results, and that the customer will have a pretty easy time getting good results. It's not going to be rocket science where you have to have a lot of help tuning it and dialing it in and all that. So anyway, that's why we use open baffle for the bass range, but everything in the speaker is somehow, I think, related to the same question of how can we not worry about the room contaminating the results coming out of it. So in that regard, I think anytime, I know I do, when I see a product that's really different, my first thought that pops in my head is not necessarily rational, but I kind of think, are they just trying to be different? Because there are some people that do that.
Yeah.
And that is not at all what we're doing. This is following research and measurements going back 30 years. This is figuring out what's happening with room interaction and trying to solve problems.
Yeah.
So you identify a problem and you work on solutions. So it's a solutions product. And what's left over, if you can make the speaker room independent and then do a competent job with the speaker itself in terms of things like linearity, then it sounds good.
Yeah.
And it sounds good in virtually any kind of room, and that's a big advantage that we have. It's just that every customer's happy kind of a thing.
Yeah.
Well,
and one thing that was interesting yesterday is this isn't a situation of you've been looking at the rest of the industry and you're like, I'm going to do this completely different and come
Exactly.
up. It's because you actually used to do box speakers. Mm-hmm. Like you have discovered these problems.
Yeah.
And now you're like, this is a problem that needs to be solved.
But see, that's true. I didn't really understand this room thing, though, that much until I got into the studio monitor and pro business.
Yeah.
Because I've been, why didn't I notice that before? Why don't other people notice it? Well, after you learn about what's actually going on with a room where the boundaries are that close to the speaker, then that's about all you can think about, because that is the big hurdle.
That's the elephant is the room. It is the room.
Exactly. Yeah, you should trademark that one.
Yeah.
So that's why. I mean, it's all just pragmatic product development. And for some, along those lines, now I'm not only just trying to do something different or whatever, but I'm really not trying to copy, or I can't really worry about what other manufacturers are doing, because I don't have all the answers. But what I'm trying to do is find the answers.
Yeah.
And we apply engineering solutions as we find them. And I think Ron you could attest as much to anybody, just in the 5-year period since you had the M3s, how far we've come.
Oh, dude.
I mean, it's just like huge.
It's crazy.
And that's just hard work. That's just testing. And
I'll cover all that in the review. I want to, I'm not trying to bait you guys, but I'll cover all that in the review. But yeah,
so like, that just shows that it is a
you've refined
work in progress.
You have refined, yeah.
Exactly.
Yeah, for sure.
And I think that's the way anything is. I mean, really large corporations can make something one time and it's done perfect, whatever. But this is a little different, and I think it takes a lot of digging and a lot of thinking about what's actually going on.
Cool.
So,
all right, well, let's do the diagrams, and then the way we're going to do the rest of the show is we're going to knock out your questions and answers. Most of them are going to be directed at Clayton. There's a couple that I'll be able to answer. So what we'll do is we'll switch to the diagrams, kind of run you through some of the principles that he was talking to me about last night. I was like, we need to show everybody this. Like, this is a good place to start. and then we'll do the Q&A, and we'll wrap this baby up, man.
All right. Okay, guys. So the big question always is why dipole, or at least dipole base. And so the answer is pretty simple. There's a problem with home audio that we don't see necessarily in larger venues like churches, auditoriums, any theaters, all kinds of larger venues where in those kinds of applications, a box speaker with control directivity is in the mid and treble anyway, is a perfectly acceptable approach. But in a home, suddenly things change because now we have a small room. Most any room in a reasonable house is way too small, and so I think to use a box speaker, we call this category small room acoustics, and the problem is kind of obvious. It's like you can see that the sidewall is right next to the speaker. So then the floor and the ceiling are essentially right next to the speaker also. And the reason that's a problem is maybe not exactly what you would think intuitively, but if you're looking, we're looking down from the ceiling. So if we have a microphone right here in the ceiling and we measure a box speaker below a certain frequency that, let's just say it's 500, let's say it's 750 hertz, it'll relate to the however big the box is, but below that point, the bass will be propagating out not only this direction, but also the other way. It's omnidirectional, so it's a complete sphere. So energy is hitting the sidewalls, this wall, the floor, the ceiling, and all of that. And depending on the wavelength of the sound that's coming out and hitting the wall, in this case, the sidewall, the return bounce will cause either an additive effect, like we'll just say +1, that will give us a peak in the response, or it will be a -1 effect to where the two are canceling. See, so, and that'll depend on this distance, the frequency, all this stuff. So the behavior is relatively complex, but therein lies that there's a problem, because when you measure box speakers in rooms, you will always see some big peak. Maybe it's 40 hertz or so.
Yeah.
But not only that, but there's usually an adjacent dip next to it. And we're talking huge. You can have 15 dB peaks and dips in rooms without even really knowing it. It's like, well, that's my house. I just set my speakers up, and why is that? Okay, well, that's because of what's called constructive and destructive interference patterns that either add to the signal or they cancel. This is really kind of scary where they're adjacent. Below 100 hertz, things get pretty ugly, where you're talking potentially, I guess, you could say a 30 dB top to bottom, peak to trough change in sound pressure level, and they're right next to each other.
Yeah.
Okay. Well, guess what that sounds like? Well, in here you say if that's centered on 70 hertz, you're going to say, well, I have no bass in that range, and then the part where the peak is produced, it sounds boomy. So you have a mixture of hot and cold, or peaks and dips that are very problematic, and the listener will blame the speaker for that and say, the speaker
either has too much bass or not enough bass.
Or in the lower bass it's boomy, in the upper bass it's mid bass it's kind of empty, blah blah blah. It has nothing really to do with the speaker. It's just the fact that the room's too small.
Yeah.
Okay. And so we have these two directions. We have the horizontal direction and then the vertical direction that are both producing these effects. Now we have a longitudinal beam, it's also going down, pressure that's going down this direction as well, that we'll just call, we'll call the Y direction, but it's much longer, so it's a lot further away. So the immediate problem is the vertical and the horizontal boundaries that are right next to the speaker. Yeah. How are we going to solve this problem? Because what's cool, I'll redraw this peak and dip over here. These are room-induced anomalies that can be eliminated. If you put a bass trap right here, the first thing that you might think is like, yeah, I'm going to lose bass, though. I don't want to suck a bunch of bass out of the room. Won't that make things worse? No, because you're not really sucking bass out. You are, if you can eliminate this reflection, then this dip goes away.
Yeah. Yeah.
See, so, and then
you're actually getting bass back.
you put that sucker in there and you go, wow, now I have bass.
Right.
And it can also flatten out this peak. Now, because it's not just frequency response. So one of the problems is that it's a time domain based problem as well. And we'll show you that in another video with, you could call it low frequency reverb if you want, but when you look at a waterfall plot or a time domain plot like that, you can see that this kind of stuff has long ringing. It doesn't, if you put a stimulus on it like that, it tends to do this and kind of settle out like a shock absorber on a car. It slowly settles back to zero. And the problem is the amount of time it takes to do that. So what we want to do is we want to settle this system down as quick as possible. Because this sounds muddy. This is what causes that muddy effect when it's stretched out over time. So I like the term low frequency reverb, even though it's not a perfect term. That's really kind of what it is. So we're talking frequency and time both.
Yeah.
Now the problem with using a room correction approach or equalization is that let's say we had an equalizer, we had a perfect 40 hertz control on it, and we just dropped the level down to flat. That actually sounds better because the peak is lowered, but it doesn't affect this time problem at all. Or
it's
much.
not addressing it.
Yeah, it's not addressing it. The reverb time's the same, or close to it. So that's why a lot of speaker designers are not super excited about room correction, although it can work and some systems are better than others. We mentioned the Dirac is really good. And,
especially like lower bass, setting up a curtain and only focusing on bass. Yeah, it does a pretty good job, yeah.
But the better approach is to do two things. One is to try to capture and terminate these reflections here and the ceiling. But how about a better idea? What if we could make a speaker that didn't have any energy going out the sides or vertically? So I'll flip it over here. And so now we have, on one side of the room, we'll make the same diagram that has the box speaker that's omnidirectional. Okay, now what happens if you make a speaker, and you can't see that, if you make a speaker dipolar. So let's say this is a top view of a dipole speaker. There's the little woofer. So this is a completely different animal because what happens now is that there's a pressure front in front of it and one in back of it.
That figure eight we were talking about before.
And it looks like that for a reason. In other words, it doesn't propagate energy out that way itself. It's just that this zone here is lost through cancellation.
Yeah,
so
90 degree cancellation.
Maybe another way to draw it would be, we have this going on, coming off the front, and the wavelengths that are long enough they're longer than this baffle dimension, they simply just wrap around the edge of the baffle.
Yeah.
And so they go around it. Well, guess what? They encounter this is positive wave, let's say, if it's moving forward. It's a corresponding negative pressure field behind it. So these are, the front and the back of the speaker are out of phase with each other.
Yeah.
And that's normally not thought of as a good thing, but it's a great thing because we want these to interact and cause cancellation because we end up with what's left over. When we get cancellation here, we're left with this.
Yeah, the figure eight.
And suddenly we have a directional bass system.
Yeah.
Bingo. Okay.
Problem solved.
Magic, and it's like Stone Age simple, but that's what we need in small room acoustics like houses.
Yeah, this doesn't work.
It doesn't work.
This does work.
Exactly. So it's almost ridiculous how simple this is and how effective it is.
Wow.
Now, so the fact that this works so well is not the question. The question is like, and I'll get into that in a second because that's kind of a separate topic, but now we have a completely different deal. Now, since And it's not just this direction. It's canceling on the top as well.
On a vertical plane as well. Yeah.
Yeah, so let me just draw it three-dimensionally then.
Yeah.
So
Painting with Clayton today at 3.
I've got my Sharpie. So this horizontal nightmare is gone because there's nothing coming, there's no bass coming out of the side of the speaker,
Yeah.
the edge of it. Now, we're only talking about bass now, wavelengths that are long enough that are related to this baffle width.
Yeah.
But it's not just the horizontal problem that's gone, it's the vertical problem.
Yeah.
Okay, so now, out of the 3 directions, 2/3 of the problem are gone.
And dude, nobody talks about the floor as a problem, and the floor is
it's huge.
such a big deal.
It's huge.
It's such a big deal.
Yep.
Yeah.
So, and these are the most problematic anyway, like I said earlier, because they're the ones that are the closest.
Yeah.
This dimension here tends many times is really quite long, like yours is 30 feet long or something. So, yeah, it's still there. You could argue, we would get issues with this, but it solves most of the problems, and you can readily hear it. It's not like, let me see if I can spend the evening trying to decipher if I can hear it, like trying to listen between 2 preamps or something. No. This is something that just like you walk in and go,
it's immediate.
The bass boom's gone.
Yeah, it's gone. It's not there. Yeah.
So now what's kind of interesting about this is, on this box thing, is that it's not related to the cost. Or almost even the design. In other words, if it's sealed, is it vented? Is it small? Is it big? Is it expensive? Is it cheap? They all do the same thing.
This is.
So you can't spend. You can't
keep throwing money at this thinking it's going to go away.
You can't spend your way out of this problem.
Yeah. Ooh.
Okay.
Wow.
Now, there are other solutions, and they come from the pro industry, that have to do with multiple driver setups on boxes that are time delayed and computer controlled. And all, But that's more having to do with microphone feedback on stage in theaters. It's not a home application.
Right.
So this is the way to solve the home problem. But then you go, well, yeah, but how come everybody doesn't, what's the deal? You don't get any bass, do you, if you do that? And
come on down.
Yeah, really. But I mean, that's where, when we talked in the interview, that's where the custom design woofer idea comes in, because dipole, you need to design the woofer specifically for this application in order to get good bass response out of it. You can't just, woofers that you buy on the market are designed for boxes, and the suspension design isn't right for open baffle. So if you have, and this is very general, so, just generally speaking, if you have a sealed box, try to draw it where you can see it better. It's what's called a second order roll off, and it rolls off this nice even 12 decibels every octave. And so that's a reasonable way to do things, but it's hard, but it requires quite a large box or a very low efficiency system in order to get, to get good bass, usable deep bass out of it. So most designers go with the vented box approach, the bass reflex approach, which gives you an increase in how deep it goes, but then it cuts off a lot faster.
Yeah.
And therein lies the problem. This roll-off rate, this is a highly resonant system.
Let me back this up right here. There you go. There you guys can see it. So this is a more aggressive slope than your 12 dB slope, and this is how they're...
But it's ringing. That's the problem, is you can hear the ringing. So it's a trade-off like everything else. You get deeper bass at your reference level, but the trade-off is sound quality.
Yeah.
And it's, that's a general answer. I mean, there are ways to get around some of that in real large vented boxes. You could actually drive that frequency down so low that it's not really a problem, but tune it so low. But in most speakers, that's the trade-off, is the quality aspect of it. So companies like Magico that use a sealed box approach is a smart thing to do because it sounds good relative, but it still has the room interaction problem that we talked about a minute ago. So you're still spinning your wheels, because who knows what's going to happen when you take this great speaker and put it in this room, because now we have all this cancellation problem going on.
Makes sense.
Okay, so An open baffle, on the other hand, it rolls off very slowly, and this is, again, generalization. It depends on baffle size and all kinds of things, but it's more like half that, 6 dB per octave.
Yeah, which would be equivalent to like
shallow.
a first order, basically.
It is first order.
First order, yeah.
And but what's cool about it is up here we have, let's say we have a woofer with a 25 hertz free air resonance called FS. Well, by the time we put it in a box, it's going to be higher because the box the air volume in there creates a stiffness, and let's say it's 50 by the time we put it in a box. When we put a 25 hertz purpose-built dipole woofer on the panel and measure it, it will go down to 25 hertz. That's now the cutoff. It's not raised because there's no box.
Right.
Now, there are some issues with level, though. In other words, it's not as efficient as this, so you may have to augment the level. But when someone asks, like we had a viewer ask, well, how do you get 32 hertz out of this
How
thing?
do you do it out of a...
It's whatever the woofer is.
Yeah.
Which is pretty
cool.
cool.
The woofer is designed to reach down that low. It's designed for open baffle. You understand the parameters. It's going to reach that low.
Well, that's true, but even if it wasn't, if we took a vented box woofer, if we took this woofer and we put it on a panel, it's still going to go down to...
It's still going to hit...
To whatever it is. Oh. It's just that the level may really be unacceptably low.
I see what you mean.
See, so... The trick with the purpose-built thing has to do with not losing as much level.
I see what you mean.
Okay,
yeah,
so...
the output of it.
Right.
Yeah,
so that's a beautiful thing, though, because now we don't really have a bandwidth problem. We don't have to make a really big speaker to get 25 or 30 hertz out of it.
Yeah.
Plug in.
Yeah. Hand that to me there.
Whoops.
You're fine, dude. I just didn't have to reach around here.
So anyway, again, the trade-off in this approach. Now this approach sounds much better because we not only eliminate the room cancellation issues because of the directionality effect that we talked about, but we don't have any cabinet vibration. We don't have any issues related to hearing the box, and we have a very shallow roll-off rate, so that shows it's not a resonant system by definition.
Yeah.
And it just sounds more natural. There's
sounds more real.
Well, there's a lot less phase disturbance than you get in a resonant system. That's changing the phase relationship. So, okay, what do you do about the base level thing? Easy. Not only do you use a purpose-designed woofer that is great, that gives you good level, add a second one. Okay, and just roll it off, make it a 2.5-way speaker, and cut this off at 90 in the case of the M3, and let this, so these work together up to 90.
What you lost here, you just made up there.
We just added onto it. Of course, you can say, well, yeah, but you have two 15-inch woofers. And you're like, well, so what?
Heck, yes, I do.
Yeah, right, I do. It's America, man. But it's 2 inches thick, so who cares? I mean, it's not like this speaker got to be the size of a giant speaker. So this is actually all just common sense stuff.
It is, yeah.
It's not any breakthroughs. You can ask anybody that's been developing these things. We're all doing very similar work because when you start doing the measurements and the science behind it, it is what it is.
Yeah.
It just hasn't gotten the traction that it should because, it gets back earlier, the retail network never had a chance to get involved in it because there weren't any products that they could buy. And the magazines kind of buy, it appears, sort of by extension, since they're primarily focused on the retail market, why would they be interested in it?
Yeah.
They think of it as DIY, but that's an old way of thinking. I mean, it's not 1995 anymore.
Yeah.
Okay. In this day and age, if you get a cross section of guys that are pretty knowledgeable, they know about this, and a lot of them own it because they know it works, and they've tried other approaches, and they know that boxes are problematic in the room because how many times have they tried it and had problems, and then suddenly, boom, they say, well, try a dipole, it'll solve that, and then they try it, it works, and they don't go back.
Yeah.
Then they tell their friends, and that's how it works. It's a grassroots movement.
Yeah.
But we're deep enough into the grassroots movement now to where it's time to just say, look, this is a legitimate alternative.
Yeah.
And there's no longer some weird DIY.
An outlier.
It's not an outlier.
Clayton
anymore.
being a weirdo, making his open baffle
Trying
speakers.
to be different.
Yeah, right. Right.
Yeah, so that's kind of the overview of what you do, but that's just the bass range.
Yeah.
Okay. There's a ton of we're dealing with all of the different frequency ranges
Yeah.
as far as how to try to get as independent of the room as we can.
All right, so now that we have a great place to start, you guys have a better understanding of the problems, the solutions, why Clayton is doing what he's doing. Let's go ahead and jump into all of your questions, or at least the ones that we're going to have time to answer. And yeah, let's knock this out. So the first question that we're going to answer is from Isaac. It is, I heard Spatial M3 Sapphires at Capital Audio Fest last year, and they were paired with the LTA integrated amp. The whole system was around 10 grand, and it sounded so amazing. I'd like to know if they have, or what they have, meaning Spatial, for home theater, and if you have open baffle subs.
Oh, okay, sure. No. We are, we're balls to the wall in production. We don't currently have, because we really, in order to really say we're doing home theater, we need a matching center speaker, and we don't have one. We've never developed one.
Yeah.
We can and probably will do a standalone subwoofer, but until we do a center, I can't really say that we're really in that business.
Yeah.
But yeah.
Cool. There you go.
2-channel.
How do you get 40 hertz of bass from an open baffle setup with a straight up one-piece baffle?
Okay, that's actually an easy question to answer, is that unlike a box, where the box and the woofer combination establish how low it goes, an open baffle speaker goes as low as whatever the driver itself, the free air resonance of the driver is. So in an M3, it's 32 hertz. The speaker goes down to 32 hertz. That's all there is to it. And we'll get in later to, if we need to, about why that's not all of the package. There are some drawbacks to that we have to work around.
Yeah.
But that's how we get such low frequency out of no box and a fairly small speaker, because that's the way open baffle speakers work anyway.
Next question comes in from William Pearson. I'm going to answer this question for you, William. You asked, really looking forward to hearing Clayton Shaw. My question is his speakers good with all types of music, or are his speakers only good for, say, rock and roll or more forward-sounding music? Is Clayton related to Alan Shaw of Harbeth? I think you can answer that real quickly.
No.
I'm going to be reviewing these. I'm going to tell you everything that I can about how they sound. I will say this, with the original M3s, they were very versatile with all different types of music. So I've had many friends come over, listen to anything ranging from Diana Krall to the Ramones to whatever, and it worked just fine, and I'll let you guys know what I think of the Sapphires. Next question, Andre Boulay, if I'm saying that correctly, I'm sorry if I'm not. These appear to be fairly similar to the Pure Audio Project Trio 15s. Apart from price, how do they compare? Mm-hmm. And I haven't really spent time with those, but I think you were saying you dig what?
It's a great product. And there's more similarities than differences, let's say it that way. I mean, what two speakers are exactly alike, but they follow many of the same principles that we do. I think, though, if you look at their product line, our focus is more on small and sort of wife-friendly. Some of theirs are quite large, but in many cases, that's fine, right?
Yeah.
So anyway, their products sound fantastic.
Cool.
And it's because they're using these principles.
Yeah.
It's no secret, or it's not rocket science again.
They're closer to each other than.
Right.
Yeah. Right.
It should sound that good.
Yeah. Cool. Benjamin Lim, next question. You asked, considering I have a rather small room, Clayton previously mentioned the M4 TurboMaster +1 sub would work better than the M3 TurboMaster. I've been using that setup for 18 months and have been really satisfied, but I'm wondering if the upgrade to the Sapphire is worth it. Will the single 12-inch output, I think you meant have as much bass as the current dual 12-inch, and does this dome tweeter sound natural? The previous Triode Master still sounds great to my ears. That's what Benjamin is asking.
That's a pretty, could turn into kind of a deep question. So I'll just kind of skim. I mean, the main thing he's wanting to know is, if you go, we have the model that replaced the M4 has one 15-inch driver instead of two 12-inch. And so when they look at that, they're thinking, am I going to lose bass? That's really, I think, what he's getting at. And in this case, the answer is no, because of the development of the new woofer, the ST15. It has a lot more bass power and it goes deeper, has more impact. So in this case, the bass is actually better, even though it's a single unit. And so it is an upgrade over the M4. And as far as the compression driver versus the dome tweeter, that's something I think we should address later, because there's a reason why I did that. But they both work well. It's just there's just different ways to achieve the end goal. But there's not just one way to do it.
Cool, man. Cool. Thanks for the question. Next question is coming in from Harley Guy 071. I'm going to answer this question. It is, as a happy, satisfied owner of the Spatial M3 Turbo S, how does his new design differ as far as a sound signature? That's my job, so I'm the reviewer here, and I'll be telling you guys as much as I can about how these things sound, and I will be using what I know about at least the M3s as a reference point. They probably sound similar.
Oh, the one you had? Yeah. Oh, yeah.
Real similar.
Almost exactly the same speaker.
So I will be able to answer that question. I know you guys are just itching to hear early impressions, and I'm not gonna tell you anything. Well, okay. I'll say this. Right out of the gates, the top end is more refined and the bass is bananas. And that's all I'm gonna say for now. Stay tuned.
Whatever that sounds like. Bananas.
Bananas. It sounds good. For 3450, the M5 Sapphire is essentially the same design. Do they have the same sonic signature? And then he goes on to say, I have dual SVS SB3000 subs. By the way, those are nice subs. I would reckon that the second woofer on the M3 covers the low bass. So does Clayton think I could still get similar soundstage with the M5 and the dual subs? And then you said something else that's not related to this, so we'll end it with that.
That's a great question. The answer is absolutely yes, because the M5 Sapphire and the M3 Sapphire are the same speaker. So that, tonal signature and how it sounds and so forth is all the same. The difference is that you could think of the M3 as taking an M5 and have an augmenting woofer that's operating from 32 hertz to 90. So it gives you more output and lift, meaning a heavier, a weightier sound and more pressurization than the single woofer. But if you're using it with subs like the key, actually, the SVS sub is really good. But when you're using a box sub with an open baffle speaker, what you want to do is do that, but then set the crossover point really low, like 40 or so that you don't kind of get that box sound. You'll get more of just the impact and the pressurization of the SVS without it kind of ruining the open baffle bass. And so I think it works great as long as but it's not always easy to blend subs. That's one of the rubs I have against subwoofers, is that it's a separate device and there's timing offset differences that cause interaction, and it's most people don't have any test equipment. How would they know how to blend the subwoofer in? So that's kind of the M3 makes it easy. You pull it out of the box and you hook it up, and that's what we did. He did yesterday.
Turn it on.
These are easy. Yeah, you plug it in.
Yeah, we're literally using my NAD M10. I mean, it's like nothing like turn it on.
Yeah. So
hey, we got good music.
It really helps because and no bass room interaction. Because the SVSs would introduce this, get right back into this problem with room interaction.
The room,
So I prefer this approach where it's all open baffle on the bass.
Yeah, I hear you. I don't even need to sell you guys on this. I love open baffle bass for that reason. You don't have that big boom type thing, and that can be fun for like a home theater experience. It's an effect. But when you don't have that and you start actually hearing the bass in the recording, like the actual real, you can't go back.
Well, that's what happened to me. That's exactly my point. When I heard that prototype back in those days, as soon as I heard it,
You're like,
I mean, okay, well, if there's a better way than this, I'd like to hear about it. So
it's true.
You kind of, it's interesting how humans all really hear the same things. I noticed this at shows where hundreds or thousands of people will come through, most of them having never heard an open baffle speaker necessarily. Maybe they did, but they all pretty much have the same reaction. Like, boy, that's a lot tighter and more detailed bass. And so it's not so something it's not all that subjective. It's pretty obvious. You know?
I agree. All right, guys. Next question coming in from Rick Escalante. I think you're being silly here at the beginning, but I'll entertain you there, Rick. You said yes. Perhaps you can ask him what shoes he wears and his first words. But more importantly, ask how an extremely clean crossoverless design could reflect on hearing the bad, meaning the amp, the source, wiring, recording, with the good, the amp, source, wiring, recording. So
that's a super great question, because it is a something we should probably, as an industry, talk more about. There's not a lot of talk about that, but just like the room problem, nobody's really talking about it. But that's been around all along, though. I mean, if you go back, I remember one example I remember that was pretty clear was in the mid-'70s, we had these big magnaplanar timpani type speakers, which would cover up a lot of information, which made it really nice to hear. You know, everything sounded pleasant. But you could tell the resolution wasn't that great. Okay, so then we also had this speaker that most of you guys have probably never seen or heard of, but it was an electrostatic speaker that was square and pretty big, called the Dayton Wright XG8 Mark III, and it was ruthlessly.
Who made that?
Dayton Wright. It was a famous designer named Michael Wright that made preamps and different things. Fantastic product, but it was so revealing that, I mean, if you put, back in those days, transistor gear wasn't really very good sounding, but the speaker required huge amounts of power. So you'd have to use actually a pretty awful sounding high-powered solid-state amplifier, and it didn't. The speaker was too good for the gear at that time. So yeah, I think that's a real problem, but it's not. But the thing about it is that it wasn't Dayton Wright's fault. Okay, they're trying to make the best speaker that they can. Their job is to make the most revealing product they can. And that's my job. I think it's a problem, particularly with a lot of the music that we like to listen to, the way it was recorded in the 70s. It's pretty bad, and it makes it hard to. How do I deal with this? Photographic lenses are kind of similar problem. Like if you have an Instamatic cheapo, $50 camera, it never really looks great, but it always looks kind of the same. But if you have a Carl Zeiss high-end lens, you have to spend a lot of time really dialing it in, working with it and everything. So it's an instrument, in other words, and so. A really highly revealing speaker is potentially a problem, but I think that our customer base tends to be guys that have owned a lot of gear and are pretty experienced. We don't have that many newbie guys that are trying to get involved and learn as much as we have guys that have had a lot of things over the years, and they kind of already know that, and they probably have already owned pretty good equipment, electronics.
They've already figured out that.
And not only that, but as we talked about last night, low-cost electronics are getting really good.
Really good.
So this whole thing about, crappy sounding electronics, it's kind of, there's really no excuse for that now, considering how inexpensive some of the things are now. That sound way better than what we had, 20 years ago.
Bottom line is resolution is kind of a double-edged sword. You want to hear the truth in the speaker? Are you sure?
Are you sure?
Are you sure?
You sure you want to take the red pill? I think there's a flip side. It's not a negative thing. It's just that you just have to be a little bit more careful. You got to be aware. Right. It's like if you buy a really high-end car, if you buy a Lamborghini, you probably are going to think about which roads you drive on. You're not going to go down those streets that are potholes and crappy. I mean, that just goes with the territory.
Makes sense. Cool. Sonic differences between the Uniwave Dome and AMT drivers in the X3.
That's a loaded question in a way. I think the best way to answer that one is...
Good luck, man. All right.
That comes under the category of there's more than one way to skin a cat. Okay, they both sound amazing, and in fact, considering how different they are as machines, it's surprising how similar they sound. I mean, they don't really sound that much different, but in a nutshell, the main, I'll just say it right now, why does the X series exist? Or, the X3 and X5, which are really the same speaker scaled for small and large rooms, but the main difference, or the main difference in the design theory, doesn't have necessarily anything have to do with sound quality. It has more to do again with application. So if you look at the X5, for example, it has a waveguide. It's a big it's a studio grade air motion transformer that has a reasonably sized waveguide, but not big enough to really call a big horn or anything. That type of device is great at eliminating the sidewall and floor ceiling interference. Its vertical dispersion is only 30 degrees, so that really helps on all this ceiling floor stuff. So anyway, what happens is that if you stand in front of your speaker and you play a track and you slowly walk, and your room is 30 feet deep, let's say, and you keep walking slowly back, you can tell that you start hearing more and more. The ratio of the direct to reflected sound changes to where you can, like, at some point you're going, I'm mainly hearing the room. Okay, and that's this whole thing about power response and all that. And so what's again, solutions-based design? What's the solution? Well, the most known solution, which comes from the pro industry, is still the dominant approach, is let's use control directivity. Let's narrow down the angle a little bit and then make it really even in terms of the projection angle with frequency. So as you go up the frequency scale, it kind of stays about 80 degrees. And dome tweeters don't do that. So we basically force it to do that with this waveguide. So by doing so, it has this effect of kind of throwing the energy across the room. It sounds less diffuse than the M3.
Okay.
So if I'm 15 feet away, I'm gonna prefer the X5 because it reduces that room volume level down.
I see what you mean.
More direct.
I see what you mean.
Gets that ratio back in line with what you would expect at 8 feet away.
Yeah.
So if the room's really big, I'll say, get an X5 or an X3. It's a little more expensive, but it's really more about the application. But in smaller rooms, I like the way this dome tweeter is sounding. It sounds really super open. Yeah. But if you get too far away from it, you lose that. You start hearing more room sound than I would like.
Would you say that there's we might not even include this, but would you say, like my room, would you say, is that like a medium-sized room?
Yeah.
Is it like...
Well, I don't know if there's any standards about what you call
right,
it.
Yeah.
I would say that in terms of the low frequency range, it's a large room because it keeps opening up,
Pass into the kitchen
and all that. So you have to consider the entire total acoustic volume when you're talking about the bass range. But in the mid and treble, it's at least a medium-sized room.
Yeah. Okay.
And it's one of the things I like about your room is that it's considerably wider than most of at least the customers that are telling us what their rooms are. That width really helps out because you get more of a big field effect. And it gets back to what we're talking about. The sidewalls aren't so dang close to the speaker. Is it? Would you say it's 15 wide or 16?
16 feet wide, and then from wall to wall, it's about 20 feet. But then, like you said, it opens up.
It goes to
the back.
At least 30, probably.
Yeah.
So that 16 wide is quite a bit wider than the typical sizes I hear, which are very commonly 12 or 13.
Okay.
So I think that's a big benefit. And anyway, that's a nice sounding room. Plus, you did room treatment.
Yeah.
And we may talk about bass trapping in a minute too.
Cool. Please ask him why he does not design his speakers with a second baffle on the side like most open baffle designs.
Yeah. Well, again, there's not just one way to achieve the result. All I care about is, what are we trying to do? Can we achieve the result? If we can do that without something that makes it either bigger or look funny or something like that or hard to set up, then I would prefer that. The M3 is a slim, clean-looking furniture-grade product.
Yeah.
If we start adding wings and things on it, it goes south real fast in terms of what I like. It just doesn't. It looks like a project.
Yeah.
We were able to get killer bass performance because of this woofer design. I don't feel like
Not a lot of bass problems with that speaker.
No, you're not sitting there going, I wish I had some wings on the side.
I'm going to try to shake off my wife's clothes later tonight.
Yeah, right. So that's great. I mean, I think that if we couldn't get bass any other way, we might not have a choice.
Yeah.
I'm not against that. But again, this is not a DIY project. This is a furniture grade product that's expensive that you're putting in your house, and it needs to look nice. And so we worked around it basically with the woofer design.
You just don't need it.
You just don't need it.
You don't need it, bottom line. Since both the M3 and X5 are very close in price, which one of them will provide better imaging, soundstage, and macro dynamics?
Oh, macro dynamics.
We're getting past micro. We're going into macro.
That's right. We're going, well, the X5. The X5 is dramatically more efficient. It's basically a big-ass studio monitor with no box.
Yeah.
It's pretty much what it is. It's a extremely powerful, it's high efficiency. It has the, if you heard it, I'll bet you the first thing you would probably say is, it wouldn't be so much about, oh, that's a lot better. You might say that. You might say that. But you would more likely characterize it like, that has more immediacy.
I see.
It's kind of like a studio monitor to be like, wow. I mean, the realism thing is crazy. Yeah. And its dynamic range, since it's so efficient and we're using these super high power efficient drivers, it has the kind of dynamics that you would normally associate with a horn speaker. So those kind of differences are noticeable right away. And that's not the same thing as saying it's better. It's just that's the design of that. That's designed for high dynamic range, further listening distance, higher sound pressure levels, things where there's pretty much no upper limit on the sound pressure level, any practical limit.
Yeah.
The tweeter easily handles 125 dB sound pressure levels. So no problem. And compression drivers too, but a dome tweeter like in the M3, it'll play loud enough for most everybody for music, but it's not a studio monitor tweeter. It's a different deal. But that tweeter's very expensive, so we could not fit, there's no way to map over that kind of tweeter into the sub $5,000 price range.
Got it. Yeah. So, I mean, I guess just to add on to that, and I think one of the questions, I don't remember if we pulled it, was like, for the guys out there that are listening to heavy metal, Tool, whatever, and they want to crank it, it sounds to me like the X5. That's it.
That's what it's designed for,
Yeah, okay. Clayton, is there going to be a kit version, and how far from the wall and the size of the room?
No.
No to everything.
No, Danny does an incredible job in the kit market, and his products sound great. No reason for me to get into that market.
Yeah.
Not interested in that anyway.
Yeah, cool. And then you also asked how far from the wall?
Yeah. Well, it's a dipole, so whether it's a Magnaplaner or Martin Logan or a whatever, or a Spatial, you need to be 3 feet away or so from the front wall. Everybody calls it something different, but the wall...
Do you call it the front wall?
I call it the front wall.
I call it the front wall because it's in front of you. I don't know why this is so hard.
I used to call it the back wall because it's like what's behind the speaker, but it's confusing. Yeah. So, I call it the front wall, but that has to do with this cancellation thing again. I'll cover that in the notes the diagrams. I'll cover that.
Yeah, cool.
But yes, it has to be... Ideally, usually, the ideal minimum's 3 feet, but we've had success at 2 feet before. So it depends on the setup and toe-in angle and stuff like that.
Next question coming in is from Keith, and you are asking, how far from the back wall minimum will these speakers have to be placed? This is my only possible reservation when considering the purchase of these fine speakers. And we were talking about this last night, and one thing that I used to do with your M3s, and I could do it with these even easier, is you can
move them.
They're literally flat, so you can just
you can kind of bear hug or just kind of just like you move your wife around.
Come over.
We have a lot of guys that. Well, a customer suggested that. They're like, here's what I'm doing.
Yeah, they don't need to live way out into your room.
Yeah,
you can just move them.
Telling people that, and a lot of guys came back and said, I tried that, and it was actually really easy. You store them against the wall, basically. Yeah. And it works great. And for background music, just casual listening or cooking or whatever, it still sounds fine.
Yeah.
But when you sit down and do listening, you could, particularly a longer session, you could put them in the proper position that you have marked, and it's quite easy to solve that family problem.
Yeah, cool.
Because it's not so heavy that you can't move them around.
I too was excited about open baffle speakers, but alas, my local dealer never picked them up, and I haven't seen them at any shows. Are the drivers designed from the ground up for open baffle use? This is a great question. Do you design the drivers, or are they sourced for their ability to perform in an open baffle configuration? So essentially, do you?
Yeah, is it a purpose-made device? Yeah, let me go answer the first part of it first. The thing about my dealer never picked up open baffle. That's kind of the whole problem is in terms of awareness, is that if you went down the list of the people like us and Pure Audio Project and all that make them, we all sell direct. So of course the dealers aren't going to pick it up. They don't have access to it. The profit margin that a dealer gets is not built into the price. Some of them have already approached us. Some of the largest ones in the country have said, we get so many requests and calls about your speakers that we want to be a dealer. And I'm like, I would love that, but we'd have to completely change our business structure because we're set up to be a direct to consumer, which is of course the way everything's going. So it's a little unfortunate in a way, because if we were in a lot of big retailers around the country, everybody would have heard them, and the movement would have been of open baffle becoming mainstream would have happened earlier. In other words. Yeah. But it happened anyway because of the grassroots effect. Yeah. It's coming in, it's becoming a big deal now, but it took longer because of factory direct. Yeah. Okay, so the second part was, the woofer thing is, that's one of the reasons that a do-it-yourselfer project or experimenting is kind of weird, is that woofers that you can buy from Matasound or Parts Express or whoever it may be, they're not designed for open baffle use. So they may be a very high quality woofer, but you probably won't get hardly any bass out of them. Because they're not
QTS and all that stuff.
QTS is one of the major factors. So the suspension design and everything has to be set up for open dipole operation, let's call. Otherwise, you don't get very good results, and that kind of explains why some people say, "Oh yeah, I've heard open baffle, or I tried that." It's like, but we design our own woofers because we have to. There's no way around it as far as I'm concerned.
This is a really easy one. This is gonna be simple. What are Clayton's favorite amps to use with the M3?
Really.
Good luck, Chuck.
We only have 3 hours left, so I'll cover that. You want an answer? I'm supposed to actually answer that.
I can't believe we pulled this one out. Yeah.
That's actually a good question that I can answer without spending 2 hours on. Is that when speakers are easy to drive and they're efficient, it really makes life simpler, because not all things, but most things work really well with these speakers. So it kind of allows you to find and use what you personally like, instead of worrying so much about, is it compatible? Is it going to work? And it's more about what you like. Pretty much anything works. Even the the flea-powered SETs will work if they're high quality, if they have high-quality output transformers and power supply. We've heard that work great, particularly if you get from a 300B 8-watt and up. If it's a high-quality 300B,
get some iron behind it.
Get some good iron behind it, like you've got that Manly that you're going to.
I'll be using the Manleys
pull
with
out
them.
of the storage. That's an incredible amplifier. That's going to work great. So it's more about how good the amp is versus how much power it has.
Cool. This is along the same lines. I think it kind of is under the umbrella of the same question, but the specs page says compatible with 8-watt amps and greater. Are 8-watt tube amps going to be able to provide enough power to produce good dynamics at reasonably high volumes, or is that suggestion more for easy listening situations? So
that
8 watts,
what we just talked about.
What kind of iron do we have behind it?
Well, when I said just a second ago that if it's a good 300B amp, that it could sound really good, that's true, but there's definitely more limitations involved, and you guys probably all know that. I mean, if it's an 8-watt amp, playing at high sound pressure levels is not necessarily going to sound very good. So I think you have to keep that in mind, and that's part of the determination process when you buy an amp. and why you need to be able to return an amplifier when you try it or buy it.
Yeah.
Because you know, you get a lot of different opinions when you ask people.
Yeah.
And manufacturers tend to be optimistic because they want to sell the amplifier. So I think you just have to try things. But that gets back to what I just said a minute ago. What we found is that certain amps that we tried just, man, you couldn't believe the power coming out of. And I'll just mention one again because it's one that I had that kind of shocked me. It was probably 3 years ago or so, but we did a show with an amplifier called the Audion brand. It's a British guy, well-known guy, but it's made in France. So Audion Silver Knight SE, I believe is the name of it. So it's a 300B 8-watt amp, killer output transformers that they make themselves. And we were like going, you got to be kidding me. The bass,
like bananas.
Bass control.
Yeah.
And loud. And you're like, wow. So, and then other 300B amps, they're just like, they're soft and
they
loose.
fall
and
flat.
Yeah, and they're not dynamic. So, yeah, I can't stress enough that if you're going to buy a 300B, buy a good one. Otherwise, forget it. Because if you don't buy a really good one, you're much better off buying one of these latest generation Class D amps, which sound incredible.
Great, yeah.
And because that's going to work for sure.
Yeah.
But the 300B thing, you have to kind of, you got to be more strategy involved with that.
Cool, that makes sense. Next question coming in, I think is from me. This is from Hang Fire, and you are saying, Ron, of all the YouTube reviews or videos that I have watched, listened to about spatial audio products, the only music that they demonstrate is the music that I don't listen to. Please ask Clayton to play some good old hard rock music to let me hear what these babies can do. I love rock. I love classic rock. So stay tuned, pay attention, make sure you're hitting the bell notifications so you know when I'm dropping the videos. I'll be doing exactly that. Yeah. So not a problem. Next question coming in from Michael Walker. Expectations high along with price. Any models that incorporate some of the tech at lower price? I have kids that need shoes.
Well, get the shoes first, and then there's a model called the M5 we talked about earlier, M5 Sapphire, which is exactly the same speaker as Ron has with the one driver, one woofer, 15-inch unit, and not kind of the subwoofer driver. So it doesn't have as much sort of bass impact, but it's still excellent. And has the exact same quality standards. I mean, it is the same loudspeaker, and there's no compromises or anything in terms of the way it's made or anything like that. It is an M3 with one less woofer. It's $3,450.
So there you go.
So it's about $1,500 less, and you get the same sound.
Yeah. Kids get shoes.
And shoes, yeah.
Kids get shoes.
Right.
Yeah, cool. How does Clayton deal with sapphire diffraction on such a wide baffle? Is the sapphire open baffle, or is it just the woofers? And can he show a spectral decay graph? Thanks.
Yeah. In fact, we are talking about we will do probably a separate. I won't be in Phoenix, but we'll do a measurements suite that shows all this stuff. What I would really like to do is Ron measure the speaker so it's not me, so that it's a third party.
I can do that
because he's getting good enough now to where there's really no problem with the quality of his data from what I can tell. So I would rather him do that. We can show a waterfall plot that shows the decay properties, which is pretty interesting on an open baffle. I mean, it's like really nice and clean.
Yeah, clean.
And then, but we'll show impedance, waterfall, frequency response, and polar response.
There you go.
And we'll talk about that in a second on the diagram thing. But that kind of shows that the principles we're talking about work in the real world, that you can actually see them in the measurement. And it's not just theoretical. You can actually see the benefits of it.
Is the Sapphire, is that open baffle, or is that, he's also
the M100 tweeter is not. It's a monopolar driver.
Okay.
Yeah.
So there you go. And let me just see here. How does Clayton deal with the Sapphire diffraction on such a wide baffle? I think it's because it's such a wide baffle. You don't.
Yeah, that's a little more complicated area than you might first think about, and a lot of that depends on frequency and the properties. But just a couple of comments might be is that it doesn't, for one thing, work the way that you think.
Yeah.
Meaning that a dome tweeter, if it has flat on-axis response by nature is going to be fairly directive up in the above 5 kilohertz or so. So there really isn't any energy that's kind of like traveling along the surface that could then diffract. So it's not near as big of a problem as as you would intuitively think it might be. And then if you go low enough in frequency, when you start getting down into the mid-range area, then you're getting the dipole cancellation effect, which solves that. So it's just canceled on the edges. So I'm not saying that it doesn't, all speakers have diffraction, but in terms of the list of things that are audible problems, that's actually further down the list than you might think.
Cool.
And I personally like the M100 is going so low down to 575 hertz. I like the way it measures and sounds in terms of having a big launch pad for these longer wavelengths that are coming out of that driver. It wouldn't work well if the baffle was small for that type of driver.
Are they only offered in walnut or sapelli?
Yeah, it's actually, I think Sapelli is the way.
Sapelli?
I call it Sapelli. But yeah, in terms of finishes, the M5 and M3 both have veneered front panels. It's a separate panel that's bonded onto the main heavy panel. And so we have 3 wood veneers in that range. Maple, which is a real light kind of color, light maple. And then a standard American walnut, flat cut. And then we have the Sapelli, which is a pretty cool looking wood because it kind of has a striped, almost kind of a gold tint to it that's iridescent. So when you move your head, you can see the brightness change of the stripes. I really like that. It's a little bit like some of the mahoganies that you see, but lighter. It's not as dark. But we found through experimentation how flexible Sapelli is as far as the ability to take stains. So we can tint it darker. The gentleman that owns Anti-Cables is a great designer himself, speaker designer, Paul Speltz. He ordered a pair and said, can you make dark, a dark Sapelli that looks more like...
Yeah, that's killer.
That looks more like mahogany. It's like, we actually can. We use walnut stain on the Sapelli.
Wow.
It looks really cool, and that wood's nice that way. It's flexible, that you can tint it, and it absorbs stain real evenly. So then we also have, as an option, it's an upcharge of, I think, $200 because we have to send it out to a painting house, but we have red, white, and black paint, which we've always had in the past. We did a white pair for, whichever guy on there, Snow Puppy, one of those guys.
Okay.
And instead of just making the front panel white, we made the back panel white and left the base black like it is.
That's cool.
Oh my God,
that's got to look clean.
And there'll be a rotating image of all of those things on the website when we finish it. And I like that. And I think it would look cool in red also. It's red all the way around. But
that's cool.
Whatever works.
Cool. Obviously would like setup info on the Sapphire 3s, but also general suggested room treatments. Ray, I'll be covering a lot of that throughout the review process, so I should be able to help you with that, so stay tuned. Room treatments are really important for sure, but I will say that when it comes to Open Baffle, that's about as much forgiveness when it comes to room treatment as it's going to get. So I will be covering all of that, so no problem. Next question is coming in from Stuart Markley. And you are saying, I am intrigued by the tweeter not using a high-pass filter. Sending out a band of energy to an electrodynamic driver always results in increased distortion, reduced power handling, and power compression. The tweeter design must somehow incorporate some form of internal filtering. P.S. After reading a post on Audio Circle from Clayton, the tweeter uses a mechanical filter to deal with the low frequencies. This is similar, but the inverse of a whizzer cone on a tweeter, so on and so forth. So essentially, what are we doing here?
No, he's right. I think if a tweeter obviously has a little tiny voice coil with real fine wire and very limited excursion capability, so if you start pumping low frequency energy into it, it'll over excurse and break or blow up or whatever.
Yeah.
So the mechanical part that he's talking about has to do with the suspension design. This is based on a Peerless, a really killer driver that Peerless makes. That's a new sapphire ceramic system, and we basically just had them tweak a bunch of things that increased power handling. And one of them was to get a longer throw suspension system that you can see it. I mean, it's right on the front. You know, I mean, you can see the way the diaphragm looks. But so we you can't completely solve every problem, but if you see the back of it, you'll see, maybe Ron can show a picture of the back of the tweeter.
I will.
It's you
guys are probably looking at it right now as we're talking.
Okay. It's all heat sink. I mean, the thing just has massive heat sink area. So then we also had them add ferrofluid and everything that we can do to not only, to improve the excursion capability, because we're going down to the lower frequency range, but also how effectively we can get the heat off the voice coil and dissipate the heat. So, but yeah, we'll get into that later. We have added a backup safety plan just in case. That's basically an excursion limiting device, just so that we don't know what people are actually doing in the field. We ran it straight out for the first 6 or 8 months and didn't have any problems at all, didn't pay any attention to it. But we had a couple of people that that blew them up, and so it's possible. So our implementation of the excursion limiting approach solved the problem, which was not a big problem to begin with. But it's, as a manufacturer, it's somebody else is now using it, so you just want to go, well, we need big safety margin built.
Got to make sure. Yeah.
So it. In fact, we were playing it loud enough last night. It was pretty surprising how loud you can not have any problems.
Oh yeah, for sure.
But it is challenging, and what you're saying is absolutely correct. So it's an engineering challenge like everything else. I mean, you just have to work around it.
When you sit down with them, will the Iota VX stack be a good match for them, or will I have to save up for a new amplifier, DAC, and preamp? I'm super excited for the review to come out. I will certainly be happy to answer that question because I do have the Iota VX and I have the PA3 additional amplifier that gives a little bit more wattage. And so I will be trying everything. I'll be throwing everything at these speakers.
And you have that little SPS amp, too.
Yeah.
Isn't that a difference?
Yeah, a little $500 SPS.
How much power does that have?
It's like 100 watts.
Okay.
Yeah, no, I think it's 150 watts.
That'd
Streaming,
be interesting, too.
Yeah. I'm going to try everything, man. We're going to try stuff starting at $400 all the way up to 10 grand, if not more. Why not? Let's try it all.
Well, exactly. I think that's great. I'm glad you have that many amplifiers.
Yeah. I'm an audiophile.
There you go.
I got a problem.
He keeps claiming. Yeah.
Thank you so much for hanging out with us. And
thank you very much.
Yeah.
That was fun.
All right, guys. Bye.
Later.